Hello, and welcome to the Writers and Illustrators of the Future podcast. This is John Goodwin, your host. This podcast is dedicated to the aspiring writer and artist and will provide inspiration and tips from top professionals in the field. If you've been listening to this podcast or are new to it, I thank you very much. I would also appreciate if you took a moment and followed it on whatever platform you use to listen to your podcasts. I have known this week's guest for at least 20 years. He is that guy who used to read science fiction as a child and dream about making those visions come true. And he is doing just that. Robert Hogg is the Deputy Mission Manager for NASA's Mars 2020 project, NASA's latest Mars rover. Robert began his career at NASA in 1997 as a flight software engineer on the Deep Space One spacecraft, which tested 12 advanced high-risk technologies in space and returned priceless images from Comet Borrelly. The Perseverance rover will search for signs of past life on Mars using 7 advanced instruments, capturing the most promising soil and rock samples using a drilling and caching system to return to Earth with a later robotic vehicle. Welcome, Robert.
Thank you very much, John. Good to see you again here.
Yeah, no, this is great that we're able to do this because I think it's going to be really inspirational for aspiring writers, or actually for that matter, I think we're going to have a lot of advanced writers also wanting to listen to this podcast to get some of the, some more facts and figures about what really is happening in our current level of space exploration. So anyway, well, we'll get into your role at JPL, but to start, was there any science fiction author or novel that inspired you to pursue robotics when you were a pup?
That's a great question. I'm glad I get to talk to your science fiction fans and the folks who listen to this podcast, because I am a huge science fiction fan and fiction, and I did a lot of reading when I was younger, and yeah, that has led to living science fiction to a greater or lesser degree here over these last years. I have read all kinds of fantasy and sci-fi. I've read Isaac Asimov, Battlefield Earth from L. Ron Hubbard, who you know is one of my favorites. I've read the Wheel of Time series by Jordan, and Brandon Sanderson finished that off for him. And to your question, on being kind of inspired when I was younger, it was such a great playground of fantastical realms and other planets to get me thinking about all kinds of amazing things that might be possible. And then I kind of set into a path when I was younger on, hey, maybe I can do some wild things with robots along those lines. And it seems like, the whole computer thing is coming along nicely, and a robot is essentially a computer. Something is a computer that can interact with the environment, right? Sense what's going on with the environment and then act in the environment. And so that led me into this whole area of exploring space with robots and exploring the solar system and the surface of Mars with robots. So for sure, science fiction let my young mind adventure when I was younger through all those different stories. And yeah, it's just been a great ride.
Well, that's great. I have a question. You mentioned Asimov was one of your favorite authors. His 3 rules of robotics, how much does JPL follow that?
Yeah, that's a great question. Yeah, so I'd say we follow it pretty closely. And we're not to the point, I think, as a society or the evolution of engineering and technology where we have to worry too much about some of those rules. But I think we're in good line with all 3 of them going forward. Our robots tend to do exactly as we say, and no more and no less, and so not much of a danger of to people or themselves. Well, actually, we do train them to not harm themselves over there on the surface of Mars, because you can't just send out a technician to go and press the reset button or fix a screw that's loose. So they really need to be able to operate by themselves and stay safe on their own. And we can get into that in detail if you'd like in
Sure.
your podcast here.
Absolutely. So, just part of the thing for this podcast is you mentioned that you really like Battlefield Earth. L. Ron Hubbard wrote in his introduction Science fiction does not come after the fact of a scientific discovery or development. It is the herald of possibility, it is the plea that someone should work on the future, yet it is not prophecy. It is a dream that precedes the dawn when the inventor or scientist awakens and goes to his books or his lab saying, I wonder whether I could make that dream come true in the world of real science. And that's just exactly what you're doing.
That's amazing. Yeah, that's such a great quote. There's a great interplay between sci-fi authors creating something, first in their minds, and then laying it out for their readers to explore, creating things that have never existed before, like ever in the history of humankind, and then engineers and scientists thinking about some of those ideas, and then figuring out, hey, that's an interesting thought. Maybe something could fly above the surface of the earth, and we don't just have just drive around on wheels. Or maybe we could send something over there and see what those canals on Mars are, and get in touch with the civilization over there, or whatever. Right? It can cause big shifts in the whole technology evolution and levels of skill of a society. And then vice versa, I think it's an interplay or a cycle that then science fiction authors, again, who are incredibly creative, maybe listen to this podcast and hear something about how Perseverance, the rover, is operating over there, and then they can go off and use that to feed some crazy story about some adventure that happens on Mars, and you discover a trap door, and down you go into the Alice in Wonderland over there on Mars. So I think that's great, and I think there's a nice flow both directions, particularly fiction to engineering, but the other way as well. It's fascinating.
Yeah, in the past, we've had a couple speakers from JPL, keynote speakers for Writers of the Future.
Oh, cool.
We also had the director of of NASA's Ames Research, who also was a keynote speaker, and they all spoke about how their start was reading science fiction that inspired them.
There you go. So NASA Ames that's great. I think there's 12 NASA centers, and so he's the director, the head of an entire NASA center. At JPL, we have somewhere between 5,000 and 6,000 people. I think it's closer to 6,000. So that person at NASA Ames is responsible for a huge chunk of what NASA does, and the research and the flight projects that they're working on over there. So I'm happy to hear that he also was inspired by science fiction, just like myself.
Yeah, he said he got busted once in history class. He had his history book, but inside of it, he was reading a science fiction book, and the teacher caught him. So,
well, it's a good thing he was, because he went on to be a NASA director.
Yeah, he said he was just reading about the history of the future. So it didn't work. But anyway,
what a great answer. That's fantastic. I'm gonna use that.
Yeah,
I'm reading about what's going to happen in the future. That's great.
Yes. Now, when we first met, you were newly at JPL, but you'd already had a track record of helping young people with robotics, how to build and compete in robotics competitions. Are you still doing that? And what was the inspiration on that?
Yeah, so that's you're talking about the first robotics program, which stands for Inspiration and Recognition of Science and Technology. And it was founded by Dean Kamen, who's really a prolific inventor. He made his mark in medical devices and medical robots, and then he went and invented the Segway and kicked off that whole industry. So he and a professor at MIT named Woody Flowers kind of figured out that our colleges and universities weren't providing the best hands-on education or degrees that folks that graduates could use to immediately go out and just create new and exciting things in their field. And also situations similar in high school. So he started this competition to get specifically high school students so that they could figure out how to take their education, math and physics and what have you, and apply it in some way and immediately, and really to help the STEM education in our country. And so science, technology, engineering, and math, right? And I, as an engineer at JPL and at NASA, fully, wholeheartedly believed in that mission. And I actually flew to Massachusetts with a bunch of other people and went to Dean Kamen's house to get together to learn about the whole thing. And then I started a first robotics team, a high school team, and with 4 local private schools. And we essentially got these high school kids making these 5-foot high, 130-pound robots from nothing, from aluminum motors, a computer controller, some motor controllers, and then even better, they go to a local competition like a in a big arena, like the Long Beach Sports Arena is the latest one that's been being used, and just like all-star basketball players, they go down and they compete in these big arenas with loud music playing, and all their family and friends and crowds are cheering, and they play these competitions against other teams. So it's a whole spectacle, and it really gets them fired up about engineering and math. And so then I went on to become the head referee for the Los Angeles regional competition. We had 60 high school teams coming there every year, and I did that for like 5 or 6 years straight. And then I couldn't do it this last year because we were landing this little robot on Mars, so I got a little busy. So I'm gonna get back to that. But yeah, for anybody who's interested, just go to usfirst.org, and they also have not just high school competition, but grade school and lower school, so that younger kids can get involved with Lego leagues and stuff like that.
Great. So, what do you do as the deputy mission manager for the Mars 2020 mission?
Let's see. Do we have 3-4 hours here, or just the? So let me start with the mission kind of high level view, and then the short version to your question is my boss and our team are entirely responsible for running the mission on a daily basis, on a weekly basis, figuring out how to make things better and being more productive, and really getting the mission done that we've all been designing and testing and getting ready for the last 7 years. So we have a whole team that sees what the rover did on Mars on any given day, and then we call it downlinks information via 4 orbiters that are going around the planet. And then so we see where it drove that day. Did it successfully drive where we wanted it to? And how are the temperatures over there? And did the arm successfully take that picture that we wanted? And then the team plans the next day, a series of commands, and we send up that plan to the rover in the morning on Mars, and then it carries out its instructions all day, and then reports back as these orbiters go by. And we repeat that cycle every day, all week, for these last months since February 18th, since we landed on Mars. So
how long does it take for a signal to go from Earth to Mars?
Somewhere between 12 and 18 minutes. I think we're about, maybe it's longer than that. I think we're at about 16 minutes right now. So that's at the speed of light. So we have big radio antennas called the Deep Space Network, and maybe you've seen them or your viewers have seen them in movies. There's one in Canberra, Australia, and one in Madrid, Spain, and one in Goldstone here in California. And so we have a giant radar dish that sends our radio signals, our commands, to the rover, and those commands travel at the speed of light. So they take about 15 minutes to get there. And then on the way back, though, we have a different setup for being able to efficiently run this rover, any rover, and that is since we don't have a ginormous antenna on the rover, it's too big. It would take too much power to get that much bandwidth coming back. So we can directly talk back to Earth, but it's only on the order of like 800 bits per second.
Yeah.
bits per second, right? Not megabits, gigabits. So what we do is we use a trick where we talk in a better frequency, where we can send more bandwidth to the orbiters that are going by overhead, including the TGO orbiter, who's with the European Space Agency. That's a European orbiter. And every time one of the orbiters goes overhead, the rover points its much smaller dish antenna at the orbiter and downloads information before the orbiter goes out of view. And then the orbiter waits until Earth rises on the other side of Mars, so that it has a direct line of sight to Earth. And then it sends the data at a much higher bandwidth back to Earth. And that also takes 15 minutes, back to your question. So we tell the rover what to do. It knows about what to do about 15 minutes later. And then throughout the day, it reports back to us via these orbiters and lets us know how it did on its instructions for the day.
Wow, that's cool. So now, what's this motor control system that you designed that actually controls all the different motors in rover?
So so I worked on the motor control system on MSL, on the Mars Science Lab, which is the Curiosity rover. And so this rover is the evolutionary child of Curiosity, which is the evolutionary child of the MER rovers from 2004. And then the great-grandfather is the Sojourner rover, which JPL landed in 1997, the week that I started working at JPL. So I worked for several years on the motor control system on MSL, on Curiosity, and then we reused a lot of the designs and some of the hardware that was left over from the MSL mission. So we started with the same motor control system that I worked on for several years as a kind of a point of departure for the design of the Perseverance motor control system. Fortunately, some other engineers came on and did a much better job of motor control than I could on this project, so I didn't have to do that this time around. And also, we got new types of motors to use on this rover using Hall effect sensors. It's a different way of figuring out where the motor is. And so that system is instantiated, is run by a separate electronics box, which we call the rover motor controller assembly. And it's got about 18 cards that source power to each motor and read the sensors, and a processor card, so a completely separate processor from the rover. So this rover has several different processors that do different things. And so that box runs all the motors on the rover, the 6 wheels, drive motors, the 4 steer motors that allow us to turn in place, the 5 motors on the robotic arm, our 7-foot-long giant robotic arm, 3 motors on the remote sensing mast, 2 motors on the high gain antenna. So that box runs all the motors on the rover and allows it to move across Mars and do communication sessions and point the remote science instruments at the rocks that we're trying to zap and the rocks we're trying to itch.
That's good. And then, does that also control the helicopter?
It does not. So glad you brought the helicopter. Yeah,
The helicopter is so cool.
So this time around, John, we decided to send a helicopter to Mars, tucked in on the belly of the rover. It's funny when you tell people that we sent this little helicopter to Mars, and this was my reaction. Like, what? You can't fly on Mars, because the atmosphere on Mars is about 1% of Earth's atmosphere. So what I tell my students is, if you wave your hand at your face, like you're fanning your face to cool yourself off,
yeah,
you would feel 1/100th of that if you did that on Mars. So it's very, very thin atmosphere. But turns out if you have a relatively light helicopter and you make blades that are much fatter, carbon fiber blades, much fatter than an Earth's equivalent helicopter, and you spin them at about 2,500 revolutions per minute, you can generate enough lift to lift this tiny amount of weight up off the surface and fly it on Mars. And that is what we did over the last few months, and it was quite an experience, I have to say. It's a very long story, but the helicopter wasn't originally baseline to go on this project. It wasn't originally selected as one of the science instruments, but the then director of JPL, Charles Alachi, really wanted to push the envelope and see if we could make this thing happen. And so the JPL team working on the helicopter in 2017 or maybe 2018, they did a prototype flight in a space simulator chamber that we have at JPL. It's a 25 foot in diameter and very tall. And the key thing about this chamber is that we're able to suck the atmosphere out of it and make it 1%, just like Mars. And we can also cool off the temperature in the chamber to Martian temperatures as low as minus 120 Celsius, which is one of the temperatures we tested the rover at. So the helicopter team took their prototype, put it in the chamber. They still had an offboard computer and offboard power, and using their control algorithm and adjusting the rotors after a lot of design work over the years, they got this thing flying in 1% atmosphere. And that so then NASA headquarters gave us the go-ahead to push ahead to make the full prototype. And then about a year later, they did a full prototype test with processor on board, the batteries on board, everything on board, and all it had was a little string, like a rubber band, pulling it from above to simulate Martian gravity. Because while you can simulate Martian pressure in the chamber and Martian temperature, you're still under Earth gravity. And so you need some other sneaky way of creating Martian gravity. So it provided a little bit of pull to represent the lesser gravity on Mars. And long story short, John, it flew, and we couldn't believe our eyes. And I'll send you some video of that chamber test. It was amazing. And so then that really started the series of events that led to the NASA administrator, the person in charge of NASA, to green light putting the helicopter on the mission. And I, at that time, had spent a lot of time personally as a systems engineer working on the incorporation and accommodation of the helicopter onto the rover, because we needed to fold it up and fit it in and figure out how to power it and figure out certain digital lines that we could know how to deploy it. And so it got the green light to fly to Mars. We had to spend a lot of time, a big team effort to get it integrated into the main rover body and stow it underneath the belly. Mm-hmm. And then away it went, and it made it to the surface of Mars. So that's the backstory, and I can go into more details on the experience after that if you'd like.
Sure, yeah, that's like, because this is a brand new thing. This was like absolutely groundbreaking. Just this whole thing here of actually getting another vehicle to another planet and having it actually fly and send back information.
That's right. You nailed it. And the specific, we'll call it Guinness World Record on a different planet, not this world, is it was and is the first powered flight on another planet.
Did you get a Guinness?
So I'm not on the helicopter team. I'm on the rover team, and I will check after we're done here how that's going, because I work daily with the helicopter. I'm the interface for them on the rover side, so I've been working intimately with them on this whole thing. So yeah, this is the first time that anything has been flown outside of planet Earth, period. And it was done in such a spectacular manner. It was really so we called the helicopter field where it first flew, we named it Wright Brothers Field. And also, I don't know if you know this, we were able to get a very small piece of cloth from the original Wright Brothers plane. I believe it's called the Kitty Hawk, and that is anchored to the helicopter, and somewhere it's not going to get in the way. So anyway, it carried a memento or a piece of evolution with it from the Wright brothers plane, and it has it with it on Mars. And so, we definitely felt like that there was a tie there from that first Earth flight to this first Mars flight.
Wow. That's just amazing. Just the backstories that you're able to provide for us here. So, so for you, what's been the coolest part of this mission so far?
Well, so I worked for several years as the surface phase lead. So that means, there's different phases of the mission: assembling, testing, getting it to the launch site, launching it, and then cruising to Mars for 7.5 months, and then entry, descent, and landing, which is the 7 minutes of terror, where we find out if we successfully landed or created a new crater on Mars. So
I was actually there, JPL, not on this one, but on the one before. I was a guest there and watched the landing of that, and that went through the whole 7 minutes of terror as it was going on. That was on, what was the one just before this one? It was
the Mars Science Lab, the Curiosity rover.
Yeah, Curiosity. Yeah.
So you experienced the 7 minutes. So you experienced the terror with us.
Yeah, but it was also cool watching everybody in mission control there, watching as each step of the way, where people, like, you see the different cheers and shouts, and then when it landed, it was like everybody was like so relieved, so ecstatic.
You captured it perfectly. So imagine, so I worked with my team and my associates for years on this surface system, right? This rover. And so imagine it's coming down into Mars's atmosphere, and the short version is it's coming in at tens of thousands of miles per hour, and then it uses a heat shield to slow down, but Martian atmosphere is not quite strong enough to slow it down all the way. So then drops the heat shield, and out comes a parachute to slow it down another order of magnitude. And then we release the parachute and get out of the way of the back shell, and then use retro rockets to slow it down 2 meters per second. And then, because we're landing a 1-ton rover, imagine the amount of force that's needed to slow a 1-ton rover down from 30,000 miles per hour to 0 miles per hour. It's a lot of force. So those retro rockets are kicking down a lot of force, and they can kick up debris, rocks and pebbles and dirt that will damage the rover and our sensitive instruments. So we have the retro rockets. We have to remove the retro rockets distance-wise from the rover itself. And so we have this thing called the sky crane, where the rover is lowered from the retro rockets from the descent stage on cables with a data cable. And then it's I think it's 10 meters or something, 20 feet away, something like that. And it lowers the rover down to the surface of Mars with the descent stage 20 feet away, or maybe 30 feet away up higher. And then it releases the cables and flies away. That whole sequence happens in 7 minutes. So imagine working on something for 7 years, right? Every day, all week, all year. And then you find out in the next 7 minutes whether it survived or not, and whether we have a surface mission or not, and get to go exploring Mars with this amazing instrument suite and try and find samples for the first time to bring back to Earth. And all that is determined in 7 minutes. And you have no control over the 7 minutes. All that has to happen autonomously, because it's 15 minutes away by the speed of light. So back to your question, the most exciting, biggest moment for me was the fact that we successfully landed. And in fact, I was the tactical mission manager on shift, running the surface team. And so right after landing, the entry, descent, and landing team passed the keys of the rover over to me and my team to take it and do our first shift on Mars. And so I got to experience that up close and personal as the tactical mission manager. And we thank the EDL team and the cruise team for getting us there, and then we got right to work on the initial checkouts and deployments that we needed to do with the rover. So that I will never forget, an experience I will never forget, being there and knowing that she survived on the surface, and we have a hope of having this glorious, surface phase ahead of us.
Wow.
The second one, if you're up for another moment,
sure,
was when we got to fly this helicopter on Mars for the first time. So I'm trying to make a long story short. We got the helicopter packaged up to the rover. We got the rover to the surface, but we need to safely get the helicopter off of the belly of the rover. And because the helicopter needed to stay so lightweight, the solar cells that it has to power itself after disengaging from the rover were not incredibly huge. They need to be lightweight. So it had enough power to charge up and get ready for 2-minute flights. And also it needed a lot of power, a lot of energy to survive the Martian nights, which are very cold. So it needed enough energy to keep its electronics box warm so that it didn't have a problem during the night. So again, long story short, that meant that once the helicopter was dropped from the belly of the rover to the surface of Mars, we needed to uncover the helicopter and expose its solar panels to light within 25 hours, no fail. Otherwise, the helicopter might not survive the night, and it would be, a catastrophic and sad end to the helicopter mission if it made it all the way to the Mars and we couldn't, do a good job of deploying it and giving it solar energy. So my team was in charge of that, and I directly worked on that and ran that whole deployment. So over a period of a week, we swung the helicopter down, deployed 2 legs, locked it into place, deployed the other 2 legs, and then we created a very special tactical shift where we were doing two-way communication directly to the rover using that 800 bits per second to see, to verify that it dropped to the surface. And it was terrifying, as I described, because we really needed to make sure that this thing was going to make it so we could do the technology flights. And we pulled it off. We successfully deployed it. We had the rover drive away automatically after it knew that it was deployed, to give ourselves a better chance of getting the deployment done if a human had to step in. But the rover autonomously drove away, uncovered the helicopter solar cells to light, and I breathed a huge sigh of relief that we were able to deliver it safely to the surface of Mars. And then as the cake or the cherry on top, I was again, because I was so involved with the helicopter and their team, I was the rover mission manager on shift when we did the first flight on Mars. So Dr. Justin Mackey, who's our imaging scientist and chief imaging engineer, was on shift, part of the team that I was running that day. And so he was looking at images from the rover that the rover captured of the helicopter's first flight. So the helicopter was about 60 meters away, about 180 feet, and we captured, using thumbnail movies or a low-res movie, the first flight in the history of humankind. And we got those little thumbnails down first, and then we got higher resolution pictures down. So I was in our control room, standing next to Justin and looking over his shoulder, and he was refreshing, waiting for these images to come, getting ready to show them. And the whole helicopter team was there looking at their instrumentation to see how the accelerometers and the gyros did on the flight. And we got these images down, and I'm looking at this tiny little blur, this pixelated little thing on the screen that's the helicopter. And he said, "Okay, we got the images," and he's flipping through them, just like you'd flip through pictures on your computer. And then all of a sudden, because we didn't have every single frame, it jumped up into the air, because the first flight was 10 feet high. about 3 meters high. And I was sitting there next to him going, oh my God, it made it up into the air. It's flying, it's stable. And then I was just waiting to see if it was going to land, because as you know, and I'm sure everybody knows, it's all about the landing as well, as far as danger to a flight vehicle. And then a few more frames skipped by, and it landed successfully, and we just went nuts and celebrated that this thing had actually pulled it off. So it just did this very simple flight, 10 feet into the air, hover for 30 seconds, and then drop back down. But that was enough to prove, just for the first flight, that you could do controlled, powered flight. And then the team went on to do, now we're up to we just did our 8th flight over this last weekend. And so the next flights after that got more and more sporty and faster. We hovered and then turned in place, and then came back down, and then did an offset by a few meters, and then back towards the rover. And then we did flights of over 100 meters, traveling across the surface of Mars at 10 meters above the ground, about 30 feet above the ground, taking images. And so the helicopter is still going strong. And so now we're using it, we're calling it an extended operations demo. We're now done with the tech demo aspect of it. So we're using it for an operations demo to see how a helicopter can work with a rover on Mars, exploring the surface of another planet. And the science team was able to use one of the high-res color helicopter images to pick out a science target. And it's just a huge success, John. The helicopter team are all heroes, and this is a big feather in the cap for JPL and for NASA, and really the whole country. And I think is a great inspiration for not just this country, but everybody who lives on planet Earth here.
Oh, that's great. So because it's got on the helicopter, just one line question: that how long can it actually operate before it needs to go down? Is it like a 2-minute type of a thing where it's got power? Or can it go 5 minutes? Can it go 10 minutes?
Yeah, so it does short flights of approximately up to 2 minutes, and it depends on how much energy is needed to survive the night. And in those two, so we charge. It takes all day to charge, or initially we were thinking it was going to take maybe 2 or 3 days to charge up between flights, but the solar cells are working very well, and I think dust gets blown off them, and we didn't need as much energy as we thought to survive the night. So it really only needs 1 day to charge before the next flight. But yeah, each flight is about 2 minutes or less. But it can travel. I mean, it's capable of going much faster, but so far I think the fastest that we have flown it is 4 meters per second. But if you can fly 4 meters per second for 100 seconds, only 100 seconds, 400 meters, that's longer than any rover has ever driven on Mars in only 2 minutes. And the rover takes hours and hours to cover that distance, or days. We don't yet have our autonomous navigation. We're in the middle of checking out our autonomous navigation system. So right now, because the rover is being directed by our rover planners on the ground, only as far as we can see from the rover cameras, we only drive about 50 meters a day on the rover. And yeah, with these helicopter flights, we're not there yet, but we should be in a position soon where we're going to try several hundred meters in one flight, in one of those 2-minute flights.
Got it. Now, are you able to fly 2 minutes and set it down and let it charge up for a day, then start up from 400 meters away, then pick it up again, go another 400 meters and let it stop and then charge it up? Can you do that? So
yes.
It doesn't have to come home?
Yeah, we are. Great question. That's a very nuanced question, and you strike at a key thing, which is initially in operations with the helicopter, we always flew it back to its airfield, Wright Brothers Airfield, where we knew every aspect of the terrain. We knew every inch of that airfield because we had investigated it with the rover to carry out this tech demo. So the first 5 flights, something like that, it would go out and come back and land in the same 10 by 10 meter square. But after that, after the technology demonstration was done and we'd achieved everything that we wanted to do on the technology demo, we went into this extended operations demo, and that involves, getting ahead of the rover, because we need to stay in communication range of the rover with the helicopter so we can keep commanding the helicopter. And so, for example, it flew 130 meters, I believe, south by southwest ahead of the rover. And then the rover did these shorter hops to catch up to it. And then on Sunday, it just flew, I think it was about 150, 160 meters south to another landing spot, which the rover and the helicopter have not imaged yet. So the helicopter team is now picking the best landing sites they can from orbital imagery, from the pictures that we take from orbit, from these different orbiters I described, that are not, they're very high resolution, but the spacecraft is so high up in orbit that you can't detect 5-centimeter obstacles or 10-centimeter rocks that might be a problem. So right now the helicopter team is using the best orbital imagery that they can to pick these next spots to hop to.
Got it. Okay, so now what would actually happen if either the helicopter or rover actually did discover life on Mars? I think some are looking to find only plankton or some such, or something that happened a million years ago. But what about actually finding wreckage or evidence of life? There appears to be riverbeds there, but what about sensors indicating something else there? What would happen if you did that? Would that be immediately like shut down the black walls and all the veins and put everything in complete lockdown, as this is all like amazingly new technology, and oh my gosh, what would happen?
Yeah, the men in black step in and
Exactly.
zap everybody. I think at this point I should say my opinions are my own and not of those of NASA headquarters. No, it's we are sending rovers to Mars and these other planets to find life and evidence of life. That is one of the biggest questions that I believe that NASA is engaged on, and one of the reasons that NASA exists. And NASA exists because the country wants to do things like that, and other countries want to go. The Chinese just landed a rover on Mars.
That's wrong. I was going to ask you about that too.
That is, I'm all for other countries landing on Mars and other planetary bodies and exploring them. I think the more the merrier, and so this is the first time we've had a neighbor on Mars, which is kind of cool, because up till now it's been only JPL rovers and landers that have successfully landed on Mars. This NASA center that I work at. So,
getting back to these aliens now.
Yeah, back to the aliens. Thank you for keeping me on point here. So we have fantastic orbital imagery. For a while there, I think it was better than Google Maps of Earth. We have better orbital imagery. So, I think it's down to like 1 pixel per square foot and a half or something like that. So, if there were cows walking around or square structures from the last civilization or whatever, we would have found those already. We've blanketed that planet with cameras like you wouldn't believe. So there's nothing like that. And in talking to the scientists on this project, I think they firmly believe that there is no current life. Now, I'm not a scientist, and it's just the surface conditions are so harsh over there. The atmosphere, left millions and millions of years ago, and so there's not much to protect the surface from the sun's rays, and then there's the temperature swings, and very acidic and caustic. But Curiosity discovered, and this was one of the main findings of the Curiosity rover, the MSL mission, that there's material, I'll call it clay or material, that has all of the components that life could grow in. And this was a huge question, because previously, I believe, and again, I need to say I'm not a scientist, I'm an engineer, but from what I've heard from them, we thought that maybe all the surface of Mars was extremely caustic and acidic to the point where life couldn't survive on the surface or grow. But for lack of a better way of describing it, you could take, an apple seed or some plant seeds and put a little dome, fill it with oxygen at different locations in this clay area, and just grow plants right there on the surface of Mars. So that was a huge discovery and finding. And then you mentioned these big river flows. Yeah, where we landed Perseverance is in a huge delta area in this huge crater. It's called Jezero Crater. And the reason we aim specifically at that spot in Jezero Crater is because of that giant flow, that giant delta coming into the area where back when Mars was wet and there was these big flows of water and other liquids going through, we imagined that all the components that were needed for life are there in that area. And so we're specifically targeting scientifically relevant areas of that delta of Jezero Crater to find the best samples to cache and take back. And so that brings me to the main reason that this project exists and this mission, which I should have mentioned at the beginning, and that is we are starting on the beginning of, we call it the first sample return mission to Mars that has existed. And this has been talked about at NASA and at JPL for decades on doing this, but this Perseverance, this Mars 2020 project, is the beginning of science of sample return from Mars to Earth, in that Perseverance has this whole sampling caching system built into the front of the rover, which was designed from scratch. And when we drive around to these different areas in Jezero Crater and use our incredible 7 instruments to find really scientifically interesting things, and hopefully we call them biosignatures. We've got spectrometers and incredible instruments to figure out that there are biosignatures that we're investigating. And once we find these biosignatures, we're going to take samples into these tubes and cache the tubes into the rover. And then after about a year or two of exploration and caching, we're going to take these tubes and drop them all in one particular spot so that they can be picked up by a future fetch rover. And then the fetch rover is going to take the samples to a Mars rocket. It's the first Mars rocket that JPL is working on, or the Mars Ascent Vehicle. And the samples are going to be launched into orbit and then picked up by a European orbiter and brought back to Earth. And the reason we're going through all these hoops, John, is the way that one of the deputy scientists of the project described it to me the other day is the burden of proof that what we're seeing in that sample is in fact a sign of life that didn't come from planet Earth. That burden of proof is so high that you need, laboratories and laboratories full of equipment that are peer reviewed to, with absolute certainty, 100% certainty, say, yes, we have discovered life on another planet for the first time. And we can't take all that equipment to Mars, so we're bringing the samples back here. And then we will, those samples will get passed around the world to the various labs, and they will do the research, and then they will say, yes, we have found life on another planet. And in my opinion, my personal opinion, that would be, the scientific find of the millennium, of the century. So yeah, we're not looking for men in black over there at this time. We are looking for signs of ancient microbial life, but that's because that's what we think we can find as far as proof, again, of life somewhere other than planet Earth.
Right, unless you actually find that hatch.
That's right, unless the hatch or the bowler hat where the guy left it when he was going back down his hatch. You got
exactly. So it's so exciting. It's so exciting. Now, hard science fiction is really cool if it's done right, and it's a really turnoff if it's not. So what type of advice do you have for writers of hard science fiction about getting it right? Like you live the life of science and of real life engineering, what works and not work. And so as an experienced reader, you're not an author particularly, but you're an experienced reader, and so you're a fan. What tips would you have in terms of getting science right and how to be able to find correct science?
So to answer your question, I'm gonna flip the answer on you a little bit as a sci-fi fan and fiction fan. So I read The Martian, and actually I didn't read it for a few years because I was like, going, I live this stuff every day. I don't need to read more about, the technology and the engineering of going to Mars. But one of the reasons I think The Martian by Andy Weir, one of the reasons it was so good is because he focused on the characters and the story arc and the adventure that they were having. And the science and the technology was very strong, except for maybe that fire extinguisher scene, but I won't go there. And or concept, but he obviously does research, and he knew from an engineering aspect the playground within which he was writing. And so I think he did a great job of dressing up his story and his characters with fantastic technology and engineering and science topics, but they weren't the focus of his writing. And in my opinion, as a reader and a fan, that's what made The Martian so good. So to your question, if I were to advise anybody, I would say, as always, as a writer, focus on your story and your message and your story arc and your incredible characters. And then, do your best to get it right on the engineering side, only so long as it forwards and helps the story and the characters that you're conveying. And then you'll nail it. And your engineering fans like me will be happy across the board.
Good. That's good. Now, are there certain pages on that JPL has on its homepage where a person can go into to get some of the actual science of what's happening right now?
Yes. So I can send you some links. That's one of the great things that I like about what we do and what NASA does. We take these missions of exploration and we just proliferate the information out to scientists all over the world. So for example, set up for my project right now as we speak is a raw images website. And John, every engineering camera image and the mass cam, I think almost all the cameras are now set up on this feed. They automatically get published to the raw images site. There's no middleman or filtering or anything. And so on some of these helicopter flights, we had to kind of get ahead of the media relations people who I was working with, had to get their tweets and their announcements out quick because the raw images were hitting the website. They automatically hit within minutes, I think, at this point, or seconds. And so, for example, all the raw images from the mission that the rover captures every day and that come from the helicopter just get dumped directly to the raw images site. So everybody can go and jump on there. And then as far as the other kind of scientific data, those I think are released from each instrument team because they have their own instrument, like the folks in Spain are running the weather station. The folks in Norway are running the radar instrument that finds obstacles and objects under the ground penetrating radar. So the instrument teams can release their science data, and they do, out to partner scientists that are at different institutions and universities all over the world.
This is just so cool. So they just go to JPL and it's just you type in raw images.
Yep. Just type in Mars 2020 raw images, and you can join the search for the Men in Black. And if anybody finds any lizards that don't need oxygen to survive, let me know. Send me an email. But yeah, no joke. I get on there on shift sometimes, and I crack open the latest images that come down and have a look at this new environment that the rover is driven into over 170 million miles away to see what's new and what we might have found next.
That's great. One last question here now. So you're also up because of the fact you said you were 7 years in the making of this particular mission here. Are there any missions right now that you're starting on or that's going on that's going to take us now to the next planet, or are we kind of locked and loaded on between Moon and Mars?
So we are, like I said, on the Mars sample return, we already have permission from Congress and funding to start the next phase of the Mars sample return mission, and so JPL is working on that with our European partners, and we will be launching the Fetch rover and the Mars Ascent vehicle. I think it was 2026. I think it might have already slipped to 2028. So JPL is working furiously on that, and then also we have missions that are going to Europa.
Yes, to say, well, we've got the moon, Jupiter's moons.
Yep, one of Jupiter's moons, which looks to be a really interesting moon. And so there was a lander mission. Now we're definitely doing a orbiter mission. And I've been so nose deep in this Mars mission, I don't remember the status of the lander mission. But at some point, we're going to land something on the surface of Europa and investigate that moon. And then we also just had 2 projects approved to go to Venus. And we haven't been to Venus for decades. And so just, a few weeks ago, actually, the project manager for the helicopter project was the lead for the proposal for one of the Venus missions. And so I was just congratulating her on that mission getting approval. So we'll be going back to Venus to investigate that planet. So yeah, we're gonna keep exploring the solar system, and we'll see what we can find out there.
That's so awesome. This has been so great having a chance to talk with you, Robert. Thank you very much.
Thank you. Great questions, John.
Great. And thank you for listening. Subscribe to the Writers and Illustrators of the Future podcast wherever you get your podcasts. We've also been syndicated on the United Public Radio Network, where you can find these podcasts as well by just typing in Writers of the Future. I also highly recommend you read the Writers of the Future series. These are, after all, who our judges have selected as the best of the best new writers and artists. They can be found at writersofthefuture.com, at Amazon, or wherever you get your books. Writers and Illustrators of the Future are contests created by L. Ron Hubbard to provide a means for the aspiring writer and artist to be seen and acknowledged. It is free to enter and open to amateur short story writers and artists of science fiction or fantasy. Again, thank you very much, Rob.
Glad to be here. Thanks again.